Hello students, welcome back to Clarity Concepts, Unleashing Conceptual Learning. Today in this lecture, we are going to solve numerical examples of an orifice meter. And those of you who have not yet viewed my previous lecture where I have explained you about the fundamental concepts of orifice meter and how it is used to measure the discharge, then kindly visit that lecture first and then come back to this numerical lecture. Otherwise, you will not be able to understand anything in this numerical lecture. Okay. So, the first numerical we have is an orifice meter with orifice diameter 10 centimeter is inserted in a pipe of 20 centimeter diameter. So, you have been given an orifice, a pipe with an orifice meter in between, and there is a fluid flowing through the pipe, right? So, this diameter, orifice diameter given to you is DO, which is 10 centimeter. So, I would say that given data, I have diameter DO as 0.1 meters because I will always use values in SI unit. Then diameter of pipe is given to you as 20 centimeters. So this diameter of pipe D1 is 20 centimeter, which means D1 is 0.2 meters. Okay. The pressure gauges fitted upstream and downstream of the orifice meter gives the reading of 19.62 Newton per centimeter square and 9.81 Newton per centimeter square respectively. What does it mean? They have mounted two pressure gauges and this pressure gauge P1 is showing you the value of 19.62 Newton per centimeter square and P2 is showing you the value of 9.81 Newton per centimeter square. Now see, when you use the values of pressure, you always make sure that again the value of pressure should be in Pascal because that is the SI unit. If they are not in the Pascal, you can convert that into Pascal very easily. How? Let's say P1 is 19.62 Newtons per centimeter square. Now, if I want to convert centimeter into meter, what is the formulation? 10 to the power minus 2, right? The conversion is 10 to the power minus 2. So, I know that 1 centimeter is 10 to the power minus 2 meter and square of that. So, if you take the square of 10 to the power minus 2, it will be 10 to the power minus 4. When this come in numerator, it will be plus 4. So, you can say P1 will be equals to 19.62 into 10 raised to 4 Newton and square of meter will be meter square. Simple, right? So, again, P2 can also be written in the same way. So, you can just put the conversion factor called 10 to the power 4 to convert from Newton per centimeter square into Newton per meter square. So, this is 9.81 Newton per centimeter square and multiply by a factor called 10 to the power 4 to get this meter square. Alright. Now, if the coefficient of discharge for the meter is 0.6, it means CD is given to you as 0.6. Then find the discharge of the water flowing through the pipe. You have to find the flow rate. Now, what is the flow rate formula? I know that Q actual is equals to CD into A1 into AO, that is area of orifice, under root of 2GH over A1 square minus AO square. Now, let us first find the values of each of this and then find out the final answer. So, value of CD is given to you. Value of A1 is pi by 4, D1 square, D1 is what? 0.2. Pi by 4, 0.2 square, that is what? Pi divided by 4 into 0.2 square, 0.0314 meter square. What is area of orifice? AO. Second, AO is pi by 4 DO square, cross sectional area of the orifice. What is DO? It is 0.1. This is pi by 4 into 0.1 square, that is coming out to be 0.00785 meter square. Okay. Then A1 AO to G is 9.81. We all of us know the value. A1 AO is not. What is H? Now see, H over here, I will calculate it over here. H is what? Since there is no YouTube manometer to measure the pressure difference, but they have directly given the pressure gauges, and we know that in the previous lecture of orifice meter that H will be equals to, when pressure gauges are mounted, it is P1 minus P2 divided by rho Fg, where rho F is the water, density of the fluid flowing through the pipe. What is the fluid flowing? Let me check. Is there anything given to you? Okay, discharge of water. See, water is given. So, this density should be density of water. So let me put the values. What is P1? P1 is this value in meter square, Newton per meter square. So 19.62 into 10 raised to 4 minus, what is P2? 9.81 into 10 raised to 4 divided by water density is 1000 into G is 9.81. Find out the answer. 19.62 minus 9.81 into 10 to power 4 divided by 1000 divided by 9.81. This will give you around 10 meters. So H is 10 meters. So did you got all these values? Yes. Let me find out the actual flow rate. CD is 0.6. Area 1 is 0.0314. 0.0314. Area 2 is 0.0078. 00785 into under root of 2 into 9.81 into 10 divided by area 1 square, so 0.0314 square minus 0.00785 square. Let me find the answer of this Q actual. This will be 2 into 9.81. Firstly, I'll resolve the bracket divided by 0.0314 square minus 0.00785 square and under root of that into 0.6 into 0.0314 into 0.00785. I am getting 0.068 meter cube per second. This is the final answer that you were looking for. So what does it mean? It means that the water flow rate through the pipe as measured by the orifice meter is 0.068 meter cube per second. Let me check whether the answer is correct or not. 0.068. Perfect. The answer is right. Okay, let us look at another example for better clarity. So I have an orifice meter with orifice diameter 15 centimeter inserted in a pipe of diameter 30 centimeter. So I have a pipe basically, and the pipe diameter is what? 30 centimeters. So I will say given data. Given data is given to you as pipe diameter is D1 always, 30 centimeter means 0.3 meters. I hope now you are expert in solving numericals, so you must know the conversions very quickly. And orifice diameter is 15 centimeters, so this is 15 centimeter. This is 0.15 meter directly, right? The pressure difference measured by a mercury oil differential manometer on two sides of the orifice meter gives a reading of 50 centimeter of mercury. They said that pressure difference of mercury oil. So here oil is flowing, this is oil and this is mercury. So this difference is your HM, and the value of HM they said is 50 centimeter if I am not wrong, 50 centimeters. So this is 0.5 meters. If the coefficient of discharge of the meter is 0.64, then find the rate of flow of oil of a specific gravity 0.9. So CD is given to you as 0.64 and specific gravity of oil is given to you as 0.9, and therefore density will be what? 0.9 into 1000, which is 900 kg per meter cube. So density of this oil is 900 kg per meter cube. Now you will need density of mercury as well. So I said you earlier also, there are two fluids where density have to be remembered. One is for water, one is for mercury. So please keep this in mind, because many a times in numerical people may not give you density of water or density of mercury because they treat that they are both the fluids which are used many a times in the industries. Okay. So as an engineer you must know the values. Alright, now what is the question? Question is find out the discharge. Discharge. So what is discharge? The formula says Q actual is equals to CD into A1 into AO under root of 2GH divided by A1 square minus AO square. Now if you see this time they have not put the pressure gauges on the top to measure the pressure difference. They have installed the UT manometer. So the H will have different formula, right? So firstly let us find what are the values of A1, AO, and then we will see what is H. So what is A1 first? A1 is equals to pi by 4 D1 square, which is pi by 4. D1 is 0.3. What is the answer? pi by 4 into 0.3 square, you will get 0.0707 meters square. So let me just in order to make it more clear, it is 0.0707 meters square. What is A2? A2 will be pi by 4 d2 square. d2 is 0.15. Pi by 4 into 0.15 square, 0.01767 meters square. This is A2. Sorry, this is not A2, this is AO rather. And this is your DO, right? So we have taken DO, orifice area. So CD is known to you, A1, AO you have found out, 2, G is 9.81 you know. H we need to calculate. What is H? Let us calculate H. H is equals to what? It is HM into rho m by rho f minus 1. So HM is what? HM is basically the manometric height. That is 0.5. What is rho m? Density of manometric fluid, 13600. What is rho f? Density of the fluid flowing through the pipe. So oil is flowing. So what is the density of oil? This will be density of oil, right? This will be 900. So this rho f will be rho o, 900 minus 1. So let me calculate 13600 by 900 minus 1 into 0.5. This is 7.055 meters. So H is 7.055 meters. Now we have received all the values. Just substitute the values in the formula. You will get Q actual equals to CD is what? 0.64 into what is A1? 0.0707 into what is A2? 0.01767 into under root of 2 into 9.81, that is G, into H is 7.055 divided by A1 square. A1 is 0.0707 square of that minus A0 0.01767 square. Now what is the final answer? Q actual. Let me calculate this. So I will first calculate the values in the under root. 2 into 9.81 into 7.055 divided by 0.0707 square minus 0.01767 square, under root of that into 0.64 into 0.0707 and into 0.01767. I am getting 0.1374 meter cube per second as the answer. So this is the final answer that you are looking for. So oil flow through this pipe is 0.137, which means Q actual is, if you multiply by 1000 to get liters per second, this will be 137.4 liters per second. Let me just verify the answer. I will get back to you. 137.4. Perfect. The answer is absolutely right. So I hope you understood how to solve the numericals based on the orifice meter and how to calculate the discharge using the orifice meter. Thank you so much. For such conceptual lectures on engineering topics, you can log into our website www.claryconcepts.com. Thank you. See you soon in the next class.